So we have to find the dimensions that give the largest area for the rectangle shown in the picture. Its base is on the x-axis and the other two vertices are above the x-axis line on the parabola. So we're looking at finding the area. The area is the base times the height. You'll notice the base here is according to this x-coordinate. See, the question is, should we make a kind of squarish rectangle like we have in the picture, or should we do should we draw a tall, skinny rectangle, or maybe a real short, wide rectangle? Which one should we draw? So that's the question, which one of these shapes, and the purple one is just a suggested one. But whichever shape you have, the height is the y value here at this point. The y would be the height there, and the base would be 2x's, because 1x is right here, and so the whole base is 2x's. So we can say the area is the base 2x times the height y, and the y depends on the x. So the y is the 6 minus x squared, depending on which x you use. So the area is 12x minus 2x cubed. So what we're going to do is graph this in our calculator. We'll have the area on the y-axis and then the x, and we're hoping for a shape that gives us a maximum. So let's go ahead and put that in the calculator and see what it looks like. So if you put that in your graphing calculator, you get a graph sort of like this. We see a maximum here. So this is the maximum area. It's about 11 when the x is 1.41. So going back to our picture, what we want is the x here to be 1.41. So that means the whole base would be twice that. So b would equal 2.82. And then we want to see, well, what is the y value at that time? So the y value would be the vertical height. So the vertical height will be 6 minus x squared, or 6 minus 1.41 squared. So let me put that in the calculator here. So y would be 4.01. So the height here is 4.01 and the base is 2.82. And that will give us the largest rectangle that can have two vertices on the x-axis and two vertices on the parabola.